And welcome back to Fofana Maths class. Today we are going to look at higher mathematics and then in the topic called differential equation. We've been dealing with topics at the basic level and then at the senior high level, but today we are going to look at the higher mathematics and then the topic that we'll be discussing will be differential equation. Okay, the first thing that we have to know is in differential equation we have two types of them. Okay, and then the first type is first order differential equation. The second is second order differential equation. And we are going to look at the first type of the differential equation, which is the first order differential equation. Now, before we look at how to deal with first order differential equation, we have to know the definition of a differential equation. And we have the definition on the board, which says that a differential equation is a relationship between an independent variable, say a variable x, and a dependent variable y, and one or more derivatives of y with respect to x. What the definition is trying to tell us is that in differential equation you have to have a relationship between two different variables, with one being the independent variable and then one being what? The independent variable. And the dependent variable, and here we have chosen x to be the variable which will be independent, and then y to be the variable which will be what? Dependent. And the equation should have one or more derivative of the dependent variable with respect to the independent variable. Now, so let's look at what I mean. When we talk about derivative, a derivative is when you differentiate any expression. What you have is a derivative. So after differentiating, when you look at this example, for instance, you see this dy over dx is what we are talking about, what we refer to as derivative. Okay, and then here the x which is involved here, when you look at them, we have the dependent variable which is the y. That is the one which is dividing the independent variable which is x. So y, the derivative is what? Y with respect to what? X. So whenever you are differentiating something, you differentiate the dependent variable with respect to the independent variable. So we differentiate y with respect to x. And then also it has to involve what? Any of them. So if you see an equation which involves a derivative, which is dy dx, that is what? A differential equation. Now we have to look at a differential equation is linear. So you have linear differential equation, then the differential equation will be linear if we have these factors associated to the question. Okay, now we have the first point, which is if a differential equation is linear, it means every dependent variable and every derivative involved occurs to the first degree only. Meaning if you have the derivative, okay, the derivative has to have only 1 degree. So for instance, if you have dy dx, if you have dy dx here, you see this dy dx, it has the degree is just 1. Okay, so the same way we could have the square y over what? The x squared. This one means it has only 1 degree. At a point where we will have more than 1 degree will be if you have it in this way. Then there is a square here. Here it is, the degree is more than 1. So the whole of this has more than 1. So if you see any expression involve this kind of derivative, it means that particular differential equation is not in first order differential equation. Okay, and then the next point is no product of dependent variables. It means the dependent variable, which is the y, there shouldn't be no product of it in the equation, and or derivatives occur. So it means if there is no product of the dependent variable, which is y and y, and then there shouldn't be a product of two different derivatives, meaning if you have dy dx, they shouldn't have something like dy. You shouldn't have something like dy dx times dy dx. No product of this such should happen. So if you see any equation which involves something like this, it means that particular equation is not considered as a differential equation. Now, the order of differential equation is given with respect to the derivative involved in that equation. So if you have an example like x times dy dx, this one is to the first derivative, okay, first derivative, then you have what? First order equation. But if you have it in the second derivative, meaning the square y over, that means this has been differentiated what? Twice. This question or this expression has been differentiated twice. So you have the derivative to be in the second mode. That means you have what? A second order equation. And then if you have it to be in the third, if it has been differentiated 3 times, so there you have the cube y over the x cube. Over there, that means what? You have it, you have the differential equation at the third level or third order differential. We are going to how to form differential equation. So the next thing is we are going to look at formation of differential equation, how you will form a differential equation when a function is being given to you. So here a function will be given to you in y form. Okay, so they'll give it to you f of x or f of y, then they'll give you the expression, or they'll give it to you as maybe y is equal to something. Then you form a differential equation out of the expression or the equation which was given to you or which is given to you. Now, before you can be able to form a differential equation occurs when arbitrary constants are eliminated from a given function. So the first thing that you have to do, or the first thing that you have to note, is when a function is given to you, all the arbitrary constants that are in the particular function or equation has to be eliminated. Okay, so what you do is to keep on differentiating that particular function. You differentiate until the constants are eliminated totally. There, wherever you get to, you will have your differential equation over there. Now let's look at the given example and use it to better our understanding so far as the formation of differential equation is concerned. Now we have a question which says that given that y is equal to a sine x plus b cos x, how do we form a differential equation out of this? So the first step is what? So name the equation as equation 1. Then you differentiate. Differentiate equation 1. Okay, so by differentiating, when you differentiate y, you have what? Dy. So, and it is with respect to x, so it will be dy dx. Okay, giving us, when you differentiate a sine x, you will get minus a cos x. Okay, because when you differentiate sine, you have to get what? Minus cos. That is a rule in differentiation that you have to also know. All right. Then when you differentiate b cos x, you have what? Plus b sine x. So what it means is if you differentiate cos, you have to get what? Sine. Okay. And then we're looking at the example, we're looking at giving, we still have what? The arbitrary constants in them. So we keep on differentiating until we are able to what? Do away with the arbitrary constant. Okay, so now we differentiate to the next level, which is what? D square y. If you differentiate dy dx, you get what? D square y over the x square, which will give us here, when you differentiate negative a cos x, you get negative a sine x. And then when you differentiate b sine x, you get minus b cos x. Remember, when you differentiate sine, you get what? Minus cos or negative cos. Now, after differentiating, let's see. Here we can factorize negative 1 out. Okay, by so doing, you'll be having the square y over the x squared, okay, to be equal to negative out into brackets a sine x plus b cos x, then bracket close. Then you name this as equation what? We have equation 1 here, so you name this as equation 2. Now, from equation 1, okay, from equation 1, we realize that y is equal to a sine x plus b cos x, b cos x. Okay, so y is equal to a sine x plus b cos x. Okay, now we can substitute equation 1. This is equation 1. You can substitute equation 1 into equation 2. Why? Because in equation 2 we have a sine x. Equation 1 also have a sine x plus b cos x, and then it also have what? Plus b cos x. So therefore, if this is so and it is equal to y, it means that when we putting equation 1 into equation 2, we'll be having the square y over the x squared to be equal to minus y. Okay, so the square y over the x squared will be equal to minus y. Okay, and I can decide to move the y to join the derivative here and equate it to 0. So we'll be having what? The square y over the x squared plus y equal to 0. And this, we have formed our differential equation. So looking at from the beginning, this is what I did. The first step, you differentiate the equation or the equation given to you in the question. Then you have to your first derivative, okay, in first order. This is what you have. Differentiate sign, you get negative cos. You differentiate cos, you get what? Sign here. Then you differentiate again. Since you can't do anything about this, then you differentiate again to have it in this form. Then you do the factorization. You factorize negative out. Then you have your equation 1 back. So from there, you substitute equation 1 into equation 2, and then this is where you'll be having. So when you look at this very well, we have eliminated the arbitrary constant, which are what? A and B in the original question. So the arbitrary constant that we spoke about, that has to be eliminated from the question given is A and then B. So by the time that you get here, you should be able to eliminate. So if it would have been that we still have the arbitrary, any of the arbitrary constants in the equation, then we will keep on differentiating until we eliminate all the arbitrary constants. So this will be the solution to the question, which says that y is equal to x plus a over x. Remember, we have to eliminate all the arbitrary constants from the equation, and here we have a as the arbitrary constant. Okay, so the first thing that we have to do is to differentiate the equation. Now we have y is equal to x plus a. We can choose to bring the x up to carry a negative sign. Okay, so when I differentiate this expression with respect to x, I will be having, when you differentiate x, you have a constant, say 1, all right, plus it will be minus, because when you are differentiating a power of -1 or any number with a power, the power will come down, so it will be minus. So we have a, then you subtract 1 from it, so it will be x to the power -2. That is the first thing to do. Okay, now from here I can decide to make a the subject here. Okay, so when I make a the subject from here, I will be having a to be equal to x into brackets y minus x. Okay, so I will name this equation as my equation 1. Okay, so when I name this as my equation 1 and I differentiate here, still I have an arbitrary constant here. So after naming it as equation 1, I can substitute this expression, equation 1. So I'll give this one to as my equation 2. So I can substitute that into equation 2. So I will write, putting equation 1 into 2. Okay, there I will be having the y, the x equal to 1 minus, then into bracket what? X 1 minus, okay, so x into bracket y minus x, okay, times again x to the power -2, which is this one. So a is x into bracket y minus x, then this one will come. Okay, so rewriting this one, I will be having it as the y, the x equal to 1 minus x into bracket y minus x all over x squared. Okay, now rewriting again, I will be having it x, the y over the x equal to 1 minus into bracket this over what? X, because one of the x, this x will cancel one of this x here, so we'll be having only one x at the denominator. So we can choose to leave our answer like this, or we can simplify the answer. So now we have dy dx equal to 1 minus y minus x over x. That is what we have here, the same thing over here. So we can also simplify this and have it in this way. To be equal to, if you have something like this one will come and multiply the one, a fraction, and then you are to remove the denominator. So the x will come and multiply x, you have x, then you open this bracket, which is this, all right, over x. So you'll be realizing that you have dy over the x equal to this one, and that will give us what? 2x minus y over x. Okay, and then you can also try to bring the x to multiply that, and then you'll be having your answer to be x multiplying dy dx equal to 2x minus y. And this, you have formed your differential equation. Okay, so this is how differential equation is formed. How did we do it? First, you have to put in your mind that you have to eliminate all the arbitrary constants in the given equation. The given equation has an arbitrary constant of a, just a. So you try to make a the subject, all right, first. Then you differentiate the question given to you. You have it in this form. Then you try to put a that you've made the subject into the differentiated equation. Okay, then you simplify to arrive at your final answer, and this will bring out to the introduction of differential equation and then the formation of differential equation. Now in my next video, we will look at how to solve a differential equation. So the equation will be given to you in this way, and then how to find the solution to it. So this will bring out to the end of today's section. And then if you are new to my YouTube page or my Facebook page, try to follow, like, and then share for the benefit of others. And if you have not subscribed, make sure you subscribe for more exciting videos. Have a nice day.